Hello guys, and welcome to another calculus video. In this video we are going to be doing a live solve of the Berkeley Math Tournament 2022 Calc round. So I'm pretty excited for this. This was suggested to me by someone in my Discord, a pretty good friend of mine, and so I'm going to go ahead and try and solve these problems. Based on the first one, which I just went ahead and copied over these questions. This is my first time seeing them other than when I copied them over. So this is going to be a pretty good live solve. I don't think I'm going to be able to solve all of them, but we'll just see how far we get, and yeah, so hope you guys enjoy the video. So first off, let's start with number 1. We are computing the derivative of this function right here, which clearly sine squared of x plus cosine squared of x is 1, so this derivative here is just 0, and that's going to be our answer. I also don't know if there's an answer key or anything, so I'm not going to go ahead and check. Okay. Let f of x equal x minus 2, x minus 7 squared plus 2x. Compute the unique real number c not equal to 7 such that f prime of c equals f prime of 7. Well, let's just go ahead and calculate f prime of x right here. So f prime of x is going to be x minus 7 squared plus 2x minus 2, x minus 7 plus 2. So we go ahead and plug in f prime of 7. And we're going to get 0 here, 0 here, and so it's just going to be 2. So we want to find another number that's going to let this be equal to 2. So that means if f prime of x equals 2, this means that x minus 7 squared plus 2, x minus 2, x minus 7 equals 0, but we know x minus 7 isn't equal to 0, so we can just go ahead and cancel that. And this is just a linear equation right here. We have 3x minus 11 equals 0, and so x is going to be 11 over 3. Let me just go ahead and check my math there. I think that should be pretty much correct. Yeah, so that's it for that problem. So I guess this is c equals 11 over 3. So that's our answer right there. Let's go ahead and move on. Compute integral from 0 to 1 of e to the x, blah, 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 blah. Alright, so the first thing we're going to do is just substitute u equals e to the x. So after that, we're going to end up in the integral from 1 to e. Now, notice that this right here is actually our du. So we can just go ahead and remove that. So we're going to have e to the u plus e to the u du. So let's go ahead and substitute v equals e to the u. And now we get the integral from e to the e. Now notice that again, this is just dv. So we just have integral from e to the v dv. Now integrating this, we just get e to the v. So overall our integral is going to be e to the e minus e to the e. And that is our answer. So let's go ahead and move on to problem number 4. Let f of x be a degree 4 polynomial such that f of x and f prime of x both have 20 and 22 as roots. Given that f of 21 is 21, compute f of 23. Alright, so f of x and f prime of x both have 20 and 22 as roots. Okay, so this means that f of x equals alpha times x minus 20 times x minus 22 times x minus alpha times x minus beta, and I'll actually change that variable at the front here to a. And then when we differentiate this, we want it to still have 20 and 22 as a root. And actually, I believe in order for that to be true, we can actually just do this right here. We can go ahead and make this square this right here. And notice that now when we calculate f prime of x, each term is still going to have 20 and 22 right here. So this might not necessarily be the only possible f of x, but it's enough information given the problem right here. So if we differentiate this, we will find that f prime of x will still have 20 and 22 as a root. So now we just have to find the case such that f of 21 is 21. So f of 21 is going to be a times 1 times 1 equals 21, so that means a equals 21. And that tells us that f of 23 is going to be a times 3 squared times 1 squared, or 21 times 9, which is just 189. And that's our answer. Alright, So we have this nice summation here. Now, just looking at this, I'm thinking we probably should use conjugates because we can get that. Oh, actually, if we use conjugates, that'll go on the bottom. That's not nice. Actually, right here we have n plus 3, and here we have n plus 1. And notice that that's a difference of 2, so that means actually if we complete the square here, we should have a telescoping series. So let's go ahead and complete the square on the inside. Sum from n equals 0 to infinity of square root of n plus 3 halves squared. And then instead of plus 2, we're going to get 9/4, so it's going to be minus 1/4 right here. And then minus square root n plus 1/2 squared. Minus 1/4 as well. And now this is a telescoping series, but, oh, I see what we're going to have to do here. Okay, so I'm guessing, does this converge? Does this converge? That is a damn good question. Okay, if we're talking about convergence here, I think this will converge. Let's go ahead and try this out. So we're going to go, we're going to take this limit as m goes to infinity, sum from n equals 0 to m of this right here. I'll call this an. And then notice that the sum from n equals 0 to m of just minus 1, just taking this part right here, it's going to be a total of m plus 1 terms. So minus m plus 1. Yeah, so what we're going to get here, and this limit, remember, it's a telescoping series, so it's going to just be this term at m right here. So this term at m is going to be root m plus 3 halves squared minus 1/4. And everything before that is just going to go ahead and cancel. And we also have to subtract out this first term right here when n just equals, or when n equals 0. And when n equals 0, you notice that this actually equals 0, so we don't have to worry about that. So we're just going to be taking the limit as m goes to infinity of this expression minus m plus 1. So in order to evaluate this, there's a couple different ways to do this. I'm not sure what the best method is. I think I'm just going to go ahead and use the No, I don't want to use the conjugate because it's not going to be a lot of fun to deal with. I'm guessing the answer is going to be 1/2, but I'm trying to figure out the best way to go ahead and okay, well, I'll use the conjugate right here. So this is going to be multiplying by the conjugate on the top and bottom. On the top, we're going to have m plus 3 halves squared minus 1/4 minus m plus 1 squared all over square root m plus 3 halves squared minus 1/4 plus m minus 1. Alright, wait, minus m plus 1. Yeah, so plus m plus 1, like that. And so on the top here, we're going to end up getting the m squareds are going to cancel. We're going to get 3m from this, and we're going to get 2m from this. So overall, we're going to have m on the top, and then on the bottom, we're going to have this is, sorry, I should probably show what I'm doing here. This is going to be proportional to m as we go to infinity, or equivalent to m essentially. And on the bottom, it's going to be, we have m right here, and we also have m right here, so this is going to be similar to 2m. So overall, our limit is going to be 1/2. And that's the result of this summation right here. Very nice problem right there. A lot of fun. All right, we have an integral here to compute. Okay, let's see. So let's go ahead and just work on from the beginning, from the inside here. Let's see. So on the inside here, we have tangent sine of x. So that's actually going to be sine squared of x over cosine x on the inside. So then when we go ahead and bring that out and we take the square root, and then this is going to be sine x over square root cosine x, right? Then we're going to multiply by tangent x, so we're going to end up with sine squared of x over cosine x to the third power. And then again, we take the square root. So now that's going to give us the value of this right here. So we're going to get sine x over cosine x to the 3/4 power. Then we multiply by this tangent of x. So we get sine squared of x over cosine x to the 7/4 power. Then we take the square root one last time, and we end up with sine x over, and again, we can take all these square roots because between 0 and pi over 3, sine x and cosine of x are always going to be positive, so we don't have to worry anything about that. So we're going to get sine x over cosine to the, what is it, 7/8 power? Yeah, I think that's right. Times secant x. So essentially we have integral from 0 to pi over 3 of sine x times cosine x to the negative 15/8 power dx. Let's go ahead and make some space here. And then we're just going to go ahead and do u equals cosine of x. So we'll eventually end up with the integral from 1/2 to 1 of u to the negative 15 over u to the negative 15/8 du, which is the same as 15/8 plus 1 is 7/8 times 1 minus 1/2 to the 15/8. I believe I flipped the sign there, or to the 7/8 power, to the negative 7/8 power, equals 7/8 times 2 to the 7/8 minus 1. Not so sure about that answer there. I believe I may have messed something up somewhere along the way. So I'm going to go ahead and check my work real quick. So we have sine squared over cosine. Then we take the square root, sine x over square root cosine. We multiply by this, we get sine squared over cosine to the 3/2. Take the square root, we get sine over cosine to the 3/4. Multiply by tangent, we get sine squared over cosine to the 7/4. Take the square root, we get sine over cosine to the 7/8. Times secant, we get cosine to the negative 15/8. U to the negative 15/8, and then we go ahead and add 1 to the power there. So negative 15/8 plus 1 is negative 7/8. So negative 7/8. Oh, it should be 8/7, right? We should be dividing by that power. So 8/7 right here. And then go ahead and plug in 1. We just get 1, right? And then plugging in the other one at 1/2 raised to the negative 7/8 power, that's the same as 2 to the 7/8. And so that should be it. So that should be our answer right there. Let's go ahead and move on to the next one, compute. Okay, so whenever we see limit as x goes to 0 and to the 1/x, it's probably going to be using the fact that limit as y goes to infinity, 1 plus 1/y to the y power equals e. And similarly, we can go ahead and put some arbitrary constants in here. To the ay, by right here is the same as e to the ab. And that's relatively easy to prove right there. So we're going to go ahead and probably end up we're going to end up using this probably. But let's go ahead. In order to calculate this integral, we're going to just expand cosine as a power series because it's going to be really nice just to give us positive powers. So we're going to take limit as x goes to 0 of 1 plus the integral from 0 to x of the sum from n equals 1 to infinity, negative 1 to the n, t to the 2n minus 2, because we have this t squared on the bottom right there, all over 2n factorial, right, dt, all raised to the 1/x power. We're going to go ahead and replace x with y, and y is going to be going to infinity. So we're going to get limit as y goes to infinity, and we're just kind of just replacing x with 1/y and y with 1/x. So we're going to have 1 plus, when we integrate this, we're going to get 2n minus 1 on the top, and then we're dividing by 2n minus 1. So we're going to end up getting here the sum from n equals 1 to infinity, negative 1 to the n, 1 over y to the 2n minus 1 power, all over 2n factorial times 2n minus 1, all raised to the y power. Now, if we go ahead and write out the first few terms here, limit as y goes to infinity, 1 plus, or actually 1 minus, first term is going to be n equals 1, so raised 1 over y to the 1 power over 2 factorial, and then 2n minus 1 is just going to be nothing, so it's just going to be 1 over 2y, and writing out the next term, I don't think we'll need anything after that. I think this should still evaluate to the same thing. Plugging in n equals 2, we're going to get 1 over y cubed, and then 4 factorial, so that's 24, and then 3. So this is going to be 24 times 3 is 72. So we're going to have 72 on the bottom here, all raised to the y power. Now, assuming that this term does not contribute to the overall answer, our answer will be e to the negative 1/2, which I believe is the correct answer, but I'm just going to go ahead and check using limit rules here. So I'm going to call this L. I just want to make sure that this term does not contribute. So if we take natural log of L, this is going to be the same as the limit as y goes to infinity of y natural log of 1 minus 1 over 2y plus 1 over 72y cubed. And then we're going to go ahead and put this as 1 over y in the bottom and then differentiate. Just to go ahead and check. And then when we differentiate using L'Hospital's rule, because we have a 0 over 0 situation, we're going to get yeah, so I've gone ahead and just from this I can tell that this term isn't going to end up mattering, so we can just not worry about that. And we are going to end up getting negative 1/2 right here. So our answer is going to be e to the negative 1/2. I just wanted to make sure that this term did not contribute, which was I was pretty sure about, but I just wanted to check. All right, number 8. Now we get to the difficult ones, it looks like. At the Berkeley Mart for Technology, every item has a real number cost independently and uniformly distributed from 0 to 2022. Smith buys different items at the store until the total amount he spends strictly exceeds 1. Compute the expected value of the number of items Smith buys. Okay, I do not know any probability or statistics, so this is going to be fun. Now, we can go ahead and assume that this answer is going to be extremely close to 1, because I mean, almost every item is okay, not almost every, since there's an infinite amount of items or something. I don't know. There could be, but essentially, it's going to be the majority of items are going to be way more expensive than $1, 1 unit. So most of the time, the first item that Sumit buys will put him over that limit. So we got to try and figure out a more. How do I do this? I don't really know how to deal with randomly distributed variables. Well, we could go ahead and sort of take a little crack at this. Since the real number cost is independently and uniformly distributed from 0 to 1, just to sort of get a sort of idea of maybe a strategy to solve this problem, I'm just going to go ahead and figure out the probability that Sumit will buy more than one item. So that means P, so he's gonna go ahead and pick one item, right? And this first item that he picks, it only has a 0 to 2022, so that means there's 2022 sort of there's a 1 out of 2022 chance that that item's cost is between 0 and 1. So The probability that item 1, which I'll just write as I1, is an element of 0, 1, and we can go ahead, we don't have to worry about closed or open brackets here because those points are essentially, we don't have to worry about them existing. So this probability here is going to be 1 out of 2022. So, which means that the expected value already is going to be super low. And this also means the probability that the number of items he buys, which I will call n, the probability that n is greater than 1 is this same number, 1 over 2022. So, what is the probability that he goes ahead and buys a third item? Well, given that he has not reached his limit of 1 after the first item, we need I1 plus I2 to be less than 1, right? Which means, what does that mean? That is a damn quick question. What does that mean? Well, let's go ahead and I'm going to sort of draw this out right here. So the actual cost, the price of I1 plus I2 is a number we know between 0 and 4,044, right? And let's see. It is more likely that this number lies somewhere in the middle. Is it? What's the probability distribution here? Trying to think of a visualization for this problem, but it's not really hitting me right now. Well, I know that it's not exactly evenly distributed. I'm guessing that this is some sort of Gaussian distribution, but I'm not exactly sure how to define the probability distribution here. I will come back to this problem, but let's go ahead and work on problem number 9, see if that's any easier. Okay, it is a lot easier. Yeah, so just looking at this problem, we have integral from 0 to pi over 2 of cosine of x over sine of x, natural log of cosine of x. And what I always like to do with these problems, when it's clear, I'm either going to have to substitute u equals sine x or u equals cosine x. It's just easy to see, okay, which one's on the top that's going to make it easier for me to substitute. And notice that this right here, combined with this, equals d sine x. So I'm going to go ahead and let u equals sine x. We have integral from 0 to 1 of ln 1 minus u squared times 1/2 over u du. Expanding this as a power series, we get 1/2 the sum from n equals 1 to infinity, negative sign, integral from 0 to 1 of u to the 2n minus 1, 1 over n, du, negative 1/2, sum from n equals 1 to infinity, of, this is going to be 1 over 2 n squared. So overall, we're going to get negative 1/4 zeta of 2, or negative pi squared over 24. I think that makes sense. Let's just go ahead and check. I believe I may have made a mistake here. Just trying to make sure that I didn't screw anything up. Negative sum 2n minus 1. Yeah, that should be right. All right. Ooh, man. A unit cube is rotated around an axis containing its longest diagonal. Compute the volume swept out by the rotating cube. Wow. That is quite an interesting problem. Really wish I had paper for this because I feel like it would be a lot easier if I could visualize it a little bit better. I'll try to draw. I don't even know how to draw a cube, I'm going to be honest. I'll try to go ahead and do this. So we're going to imagine a cube right here. And what I actually want to do for this problem is rather than sweeping out the whole cube, I want to figure out if there is some some section of the cube that I can take, and then I can calculate what happens if I sweep out that section, and then just do like a standard like surface integral, and have that not really overlap with any other section. So if I rotate it around this axis, I want you to imagine that I slice the cube. I want you to imagine that I'm slicing the cube right here on the face, sort of the plane created by connecting these four corners. So what that cross section is going to look like is it's going to be a sort of longer. Wait, am I tripping right now? Wait. It's going to look something like that, right? Yeah, so this side length right here is, it's a unit cube, so these side lengths are all 1, 1, 1, right? So this is going to be square root 2, this is going to be 1, and this is going to be square root 3. So I want you to imagine that instead of having a full cube, I just have this section of the plane right here, which I'm going to put in yellow. Just this first half, cut it right here. I'm just going to take this plane, and instead of taking this entire cube, I just sweep out this plane right here. I think that will cover the same volume in space as the entire cube. I believe. That doesn't help me though. Okay, well, what if instead we stand up the cube like this? We stand it on a point. So here's its lowest point and its highest point. And we let its longest diagonal go right here. Then we're going to have something sort of looking like this. So it sort of makes sense. And then what happens if I go ahead and rotate it like that? I can go ahead and make little cross sections right here, and maybe I can calculate the area of each of those cylinders. I can actually split this in half as well, so I can look at the top half and the bottom half and multiply that by 2. So I'm going to go ahead and cut it in half there. And then I know it's really hard to visualize what I'm trying to do here, but essentially I'm trying to turn this into a standard, disk or shell method problem, the kind of thing that you'd see in AP Calc, which I think is actually possible in this situation. So if I define a variable h, now h is going to vary from 0 to square root 3. We'll actually do from 0 to square root 3 over 2. So again, 0 to square root 3 would be h. We're just going, h is going to track out sort of a straight line from this bottom point all the way to this top point, which is of course the longest diagonal of the cube. Now, as h varies from 0 to square root 3, we're going to go ahead and sum up the area of these cylinders right here. And notice that this height here is actually going to end up being dh. So overall, the area of each cylinder is going to be, area of a cylinder is pi r squared h, right? Pi r squared h, which in this case is just going to be dh. Now, pi is easy. The r squared is going to be a little bit of a problem because we do need to calculate what is the furthest distance around. But I believe that shouldn't be too difficult since it should be linearly defined. So when h is square root 3 over 2, the lateral distance, so in the plane perpendicular to the path of h. If we trace out the path of h and we look at the plane perpendicular to the path of h, what is going to be the distance from where h is in that plane to the edge of the cube, the maximum distance? So the maximum distance should be the distance all the way out to one of these corners. So when h equals 0, r is going to obviously be 0. And I'm hoping that it will be linearly defined, so that means we can just make a linear relationship here. Now, when h equals root 3 over 2, the point defined by h is actually going to be in the exact center of the cube, which means that the distance to every corner is just going to be square root 3 over 2. Does that make sense? Which means, yeah, that does make sense. Which means that when h equals root 3 over 2, r also equals root 3 over 2. So we can go ahead and I really can't visualize this perfectly, but I'm going to assume that h equals r. So this means we're now integrating from h equals 0. So we're going to set up this integral right here. So the formula for our area of our cylinder here is going to be pi r squared h, and of course r we're now saying is going to be equal to h. So this is going to be h squared, and then our height of our cylinder or little disk here is going to be dh. And so we just need to sum up all of these cylinders. Of course, remember to multiply by 2 because we're only looking at half of the cube, and remember this cube, we also have to think about the other half. So we want to integrate 2 pi h squared dh from h equals 0 to h equals root 3 over 2. Again, I have really no idea if I'm doing this correctly, but let's go ahead and solve this integral right here. We're going to get 2 pi over 3 times root 3 over 2 cubed, which equals pi root 3 over 4. Now, I do actually want to go ahead and confirm this answer because I am very much not confident about it. But that is the answer that I believe should be the result to that. Again, it's really hard to actually visualize what this question is asking. A unit cube is rotated around an axis containing its longest diagonal volume swept out. Okay, so let's go ahead and go back to problem number 8 and see if I can go ahead and come up with some better ideas for how to solve this problem. So in order to figure out what the probability distribution looks like from 0 to 4044, we know that it's going to be, well, if I can't visualize this at all. It's a little bit frustrating. I'm not sure if we are going to still have a linear probability distribution. Is there an equal chance for it to be everywhere within? Okay, let's assume that out of the price of the first two items, they have an equal chance of being anywhere between 0 and 4044. The sum of those two prices. So that means that the chance that I1 plus I2 is less than 1 is going to be 1 over 4044. And that means that the price, and again, following from that same logic, the probability that I1 plus I2 plus, oh wait, I'm looking at this completely incorrectly. Okay, we are assuming, of course, that I1 is going to be an element of 0, is going to be between 0 and 1, right? So that means we need to calculate the probability that I1 plus I2 is less than 1, given that I1 is between 0 and 1. Okay, so that is a little bit of a different story. This means that we now need to calculate the probability that I2, or the price of item 2, is less than 1 minus I1. However, we don't know the value of I1 because, again, it's a randomly distributed variable. We do know it's somewhere within 0 and 1, so that's all we know. We can go ahead and make an expression in terms of I1 here. So the probability that this is true, again, I1 is an element of 0, 1, is going to be 1 over 2022 times 1 minus I1. I think that's right. I have no idea why I think that's the answer. Or times, maybe? Yeah, maybe times 1 minus I1. Yeah, that makes sense. So let's say, for example, I1 was 1/2, then our probability would be 1 over 4044, which makes perfect sense. So I believe that this is the answer. So let's go ahead and track our progress so far. So We now know that the probability that n is greater than 1 is 1 over 2, 2. Now the probability that n is greater than 2, i.e. the probability that this is true as well, is going to be 1 over 2022 times this probability right here, which is 1 minus I1 over 2022. And again, I1 is between 0 and 1, but we do not know the value of I1, and I have no idea how to account for that because, again, I'm not a probability guy. I really suck at probability. I'm going to assume here... Well, I'm going to play this as if I was really at that competition. I'm going to go ahead and assume that I can just set this equal to 1/2 because that's the most likely probability in terms of calculating the expected value. So this means that I'm going to say that p n is greater than 2 equals 1 over 2 times 2022 squared. Again, this is not how I would do it if I really had to solve this problem, but if I was in the competition, I would have no idea how to solve this problem, so I would just go ahead and do this. And then I would extrapolate from this and assume p n is greater than 3 equals 1 over 4 times 2022 cubed. I don't know. That doesn't really seem to make any sense because p I3 is less than 1 minus I1 minus I2. It's going to be even less, so I don't really know how to account for that. Alright, so anyway, in order to calculate the expected value here, we need to take the sum of the values, so the possible values, which would be our value of n. So sum of our values of n and the probability that n takes on that value. So, or the sum of our values, I guess we'll call this k, and the sum on k, or the sum of p times n equals k, right? So what this is going to look like is obviously sum from k equals 1 to infinity of k times, okay. So we know that the probability for k equals 1 is 2021 over 2022, right? Very high probability. The probability that k equals 2 is going to be 1 over 2022, or actually it's going to be the probability, I guess it's going to be the probability that n is greater than 1, but n is not greater than 2. So, I don't even know. I'm not good at probability. Alright, so I would definitely not get this problem in a competition. I barely even know what expected value technically means. So, the other problems were not too bad, but this one was a little bit nasty. So I'm going to go ahead and see if there's anywhere where I can check my answers for this. But thank you guys so much for watching this video. If you have any suggestions on how I should solve this probability problem, please let me know. But anyway, thanks for watching the video. I hope you enjoyed. I had a lot of fun with the video, so yeah. Thanks for watching. See you next time, and keep on mathing. Bye.